Hi there, I'm Hao, and this is just another video of me solving a number problem. So today we have to search in a rotated a rotated and a sorted array. So there's an integer array num sorted in ascending order, right, with distinct value. Prior to being passed to your function, num is possibly being rotated at an unknown pivot index k, such that the resulting array, blah blah blah, right, can be rotated and have like a different result. So it is no longer sorted. Right? So if we are rotating at index 3, which means this is our resulting array. So and they want us to search for a target inside the array and just return the index, right? So if it is 4, right, it's at index 0. If we cannot find the element, just return -1. Right, so that is pretty straightforward. We can just search. We can just do a linear search, right? But it is not allowed. It is required that we have to do it in log of n time, which is they use binary search. And the problem is that the array, if the array is being rotated, it is no longer sorted, right? It is no longer sorted. So it's like, so how can we do it in log of n time? Right, my first intuition is that maybe we can sort it again, right? But it takes us n log n to sort something, right? So which is like not an option here. So if we know the rotating pivot, for example, if we know the pivot is at index 3, 0, 1, 2, 3, right? Right, you know the pivot is here, right? We can binary search this part and binary search this part. We take us 2 log of n, right? Which is still log of n. So if we were able to find out the pivot, we can just binary search both ends, right? So how can we find the pivot? So let's see, if we have 4, 5, 6, 7, and 0, 1, 2. This should be our index. 0, 1, 2, 3, 4, 5, 6. So if we have a left and a right here, right, we can look at the middle element. So we have 7 elements here, so the middle element is going to be here, right? So we compare. So okay, in a normal sorted array, right, the middle index, right, the middle index nums as mid, right, had to be has to be greater than, right? Num as mid had to be smaller than or equal to nums like at the right, right, with the at the last element, right, last, right, element, last index, right. So if the element here, if the middle element is greater than, is larger than the last element, right? Which means the array has been rotated, right? So we need to set the left index, right, to mid +1, right? So we are trying to find the pivot here, right? So we can do it again. This is our mid index, right? The value at mid here now is 1, right? 1 is smaller than or equal to 2, right? Which means this portion is sorted, right? So we move the right pointer, that right equal to mid -1, right? So now our mid is here, 0, right? Result is smaller than or equal um to 2, right? Which is the last element here, right? So which means this portion is sorted. So we keep moving the right element equal to mid -1. So now they overlap, right? So we found out that okay, the left here gonna be our pivot, right? Plus one is our pivot plus one, right? Okay. So we can search from 0 to left minus 1, and then from left to n minus 1, right? These two portion. So the key idea here is that our attack velocity, right, would be 3 log of n. Log of n, first one is to find the pivot, and the next two is to find the target, right? Using binary search, because now this portion, right, 0 to left minus 1, this portion is sorted, right? And then this portion is also sorted, right? So that is log of n. I mean, log of n divided by 2 maybe, but we're out up to n because we don't know how many elements, right? So our attack complexity is log of n now. So to find a pivot, right, the key idea is that we need to keep comparing it to the last element, right? And in a normal sorted array, right, the right element, the element on the right side is always larger than the element in the middle, right? If the element in the middle is larger, then which means, so if the element in the middle is larger, then which means that our sorted array, like at the right half, is somewhere on the right, right? We are trying to find the cutoff here, the pivot, where you have the um the maximum element here and the minimum element here, right? It is decreasing. So let's say if we have in different case, if we have an already sorted array, an sorted array, right? So our mid gonna be here, right? Right. So 3 is already smaller than or equal to 6, right? Right. So it is already sorted. So we move the right filter to the left, mid minus 1, right, and continue, right? So 1 is smaller than or equal to 2, right? Which is correct. Okay, so we keep moving the right equal to left to mid minus 1, right? And now 0 is smaller than or equal to 6, right? So we move the right to here. So now they are overlap, right? So this will be our pivot, right? So we don't have the left half, right? Because left is already at 0 and left minus 1 gonna be a negative number, right? So we only have to search the right half here, right? Because the right half is starting from left to n minus 1, which means the array here is already sorted. Okay, so let's put this up. So we need to find the pivot, right? So let's create a have a function for that. Find pivot. Okay, so look left and right equal to the first and last index. So y left is less than or equal to right equals to the mid equal to right plus what the floor of right minus left divided by 2. Okay, so if the number is at in the middle is greater than the number is the last element, right? So if the number in the middle, right, is larger than the last element, which means we need to go to the right side to find like the next the minimum element, right? Else it is sorted, right? So we keep moving to the left to find the minimum element. So in other words, we are trying to find the minimum element. You can think about it that way, right? So in a normal sorted array, right, the mid element would be smaller than the right the last element, right? So we just keep like moving to the left to find the minimum element, which is 0 in this case, right? But if the mid element is larger than if the minimum element, sorry, the middle element is larger than the last element, we will need to move to the right, right? to find the minimum, right? Because the middle element is larger than the uh last elements, which means the array has been rotated, and the minimum element is has to be somewhere after the middle element. So that's why we go to the left. We go to the right here, right? Left equal to mid plus one. Okay. So we find the pivot. After we find the pivot, we need to search, right? We can do the binary search on the terrain that we talked about earlier, from 0 to pivot, right, -1. And then so if the answer is equal to -1, right? So which means if it is not found in the first part, the first half, not the first half, but like the first interval, we're gonna search the second interval, right? Pivot and the last index, okay? And then we can return the answer here. So we have binary search. But this is just a normal binary search. Right, then we're gonna be the same if num set mid is equal to the target, we return the mid. Right? Otherwise, we return -1 here. Okay. If num set mid is larger than the target, we need to move to the left, right? To right, equal to mid -1, else left equal to mid +1. And yeah, that's pretty much it. Okay. Let's see. 5 pivots, right? Let's see if we have the correct pivot. Console.log the pivot. Okay, the pivot is unified here. So let's see, in our 5 pivot function, okay, we forgot to return the left, right? So remember our pivot will be the left, right? In the picture earlier. Uh, right, so the left here, when the left and the right are overlap, we're gonna find our pivot. Okay, so let's try it again. Okay. Somehow we got -1. Let's bring out our pivot again, just to make sure that we have the correct pivot. Run. Okay, the pivot is 4 now, right? Which is 0, 1, 2, 3, 4, which is a 0 here, right? And we're gonna start from 0 to 3, right? And then 4 to the end, right? So this the pivot is correct here, which is good. Okay, so we are running the binary search on the first half, right? And that should return the result. Okay, so let's see. So we have a left and the right. So while left is less than or equal to right, mid equals to left plus math of lower right minus left equal to 2. If num submit is equal to the target, we return the mid, right? Otherwise, we move left and right, right? If num submit is larger than the target, we move to the left by setting the right equal to mid -1. Otherwise, we move to the right by setting left equal to mid +1. Okay, so let's see. Console.log answer. First part, we got -1. Hmm. Okay, so our target is 0, right? So it should be on the second half. Oh, yes, we forgot to set the answer. Yeah. Right, let's try it again. Okay. Um, okay. Yeah, that worked. And yeah, thank you for watching.